Hello, this is Pointers by Arbitrary. It is a more difficult version of the pointing arrows puzzle that I did recently, and the rules are basically the same. So, what are the rules? The rules are 1 to 9 in every row, every column, and every 3x3 box. Besides that, each arrow acts as a pointer arrow, so digits along the arrow must sum to the digit in the circle. So if this was a 1, 3, and 4, then this would then be an 8. Additionally, arrow tips point to the arrow tips indicate the distance from the arrow to a cell, which must then contain the value in the circle. So if this was, say, a 4, 3, 2, 9, then this value points 4 cells away, which then sees a 9. So that's how the pointing arrows work. There may be other instances of the same digit between this cell and the arrow tip. So you could have this be a 3, 1, 4, and then a 3 would see a 4 there because of the 4 here. Then it's fine if there was another 4 here. So the 3 isn't blocked by this 4, it just has to see a 4 3 cells away. Yeah, so those are the rules. This is intended to be slightly harder than the first puzzle that I did, so I'm probably going to spend a bit more time on it. And with that, let us begin. So right off the bat, I'm seeing two 3-cell arrows. This is also a 3-cell arrow, but it's a bit different in that case. The two 3-cell arrows that are important are these two. And the reason why is because in these 3-cell arrows, digits cannot repeat. Along an arrow, digits can repeat if they are allowed to by regular Sudoku. But otherwise, these arrows here must have a minimum digits of 1, 2, and 3. Which means that this must minimally be 6. So this must minimally be 6. Yeah. So I think what we are going to look at is these and these, because they can't be too big either. In fact, they can't be a 5, right? Well, they could be a 5. In fact, they could be a 6 as well. Oh, they could be a 6, 2, 1 to make a 9. And then 6 is like here, right? So it can see a lot of cells. Okay, well I guess these aren't very restrained then. This one also sees 6 possible cells. Okay, well then what do we look at? Do we look at these 1-cell arrows? These 1-cell arrows really just mean that this cell is equal to that cell. And so whatever cell is here, this cell... whatever cell is here, from here how many cells away you'd see that. So in fact, it cannot really see these 2 cells, because whatever you have here, say a 2, would mean that 2 cells away, there will be another 2, which fails because there's already a 2 in the box. So it can't see these 2 cells, and therefore must see one of these cells, which means it must be a 3, 4, or 5. Okay. Oh, I see. That's interesting. It can't really be... Oh no, it can. No, I'm thinking about this rule set a bit wrong. What about this? I mean, we could put in values for each of these cells. This one can only see 4 possible places, but I can't see this one because it's in the same box as this. So it can only be 2, 3, and 4. This one can't see these 2, but can see these 3. So it can only be a 3, 4, or 5 as well. Not that. So that's slightly interesting. Ah, wow, it really isn't giving us much then. This one's a bit big. This one's not that big. Yeah, this can only be up to 3 values. So can we only be up to 3? This one can also only be up to 3. Giving us a very interesting looking quintuple here. These cells must contain the digits 1, 2, 3, 4, and 5. They cannot contain anything else, so they just have the digits 1, 2, 3, 4, 5, meaning 6, 7, 8, and 9 reside in the rest of these cells. So that's interesting. 6 can't be here because this would then be bigger than 6, and therefore this would not be fulfilled. And simply 9 can't be here because this would then be less than 9. Okay, I'm not exactly sure what else there is though. These all see things outside of their box, which we actually haven't done anything to yet. I'd say this one could possibly see some arrows here. Not sure. I wanna know if there is any interactions between arrows that we are meant to see. Like if this was a 5, it would see the bulb here. So it'll put a 5 there, which means a 5 must exist somewhere, you know, around here. And this value can really only be up to a 4. So that would then be a 5. I mean that 5 can only be in one of these cells. I'm not entirely sure though. This can also be only 2, 3, and 4. I realize that now. I want to say if this was a 4 though, that's a really interesting place to see this cell. Because if this was a 4, then this must be at least a 6. Right? 4, 1, and 1. But then that would put a 6 here. Or a 6 or larger. And that does work in fact, because you could have a 9 made out of 6, 1, and 2. Oh, wait. Oh no, but then... does that work? Yeah, because you could put a 1 here. You can't put a 2 here because that sees this cell, which can't be a 6, 7, 8, or 9. But you can put it here because that could be anything. So this could... if this was a 4, then you have like a 6 here, a 1... a 6, 2, 1, and then this one will be the 9. Oh, so this can't be a 1 because it would then be here, meaning that whatever this is would then be there. So this can't be a 1. So if this was a 4, this would have to be a 6. Could it be a 7? No. Because if it was a 7, then even if you had the minimum here of 1 and 2, this would then have to be at least 10. So this can't be a 4 then. A 4 puts a 6 here, a 6 puts a 1, 2 pair here. This can't be a 1 because that would then be the same as this. It can't be a 2 because this can't be a 6, 7, 8, or 9. So in a very roundabout way, this can't be a 4. So that is some interaction with arrows that we're seeing here. I think 2 and 3 are harder to disprove because this could definitely be the value here. And this could really be any value at all. Okay. What else do we have? If this was a 4 then... no, maybe this? No, because this could be like... this could be 3 or 4. I think this could be anything. A 3 here puts a 3 there, and a 4 here puts a 4 there. A 2 would put a 2 here, which doesn't make much of a difference. Well, what can this be? 1, 2, 3, 4, 5, 6. Oh, I see. This cell we already know can't be a 1 because then these two will be the same. But it also can't be a 2, 3, or 4 because none of these are 6, 7, 8, 9. So this can only be 5 or 6, which is useful because it's on the arrow that's here. Oh, so that is quite restricting. If this was a 6, then you have a 1, 2 pair there to make this a 9. And if it was a 5, you could have a 1, 2 to make 8, or a 1, 3 to make 9, but you couldn't have a 2 and 3. So that means somewhere on this there must exist a 1. This therefore can't be a 3, because 3 would then see this cell, which can't be a 3, so these can't be 3s. And it can't be a 4, because that puts a 4 here, but 4 along with whatever is here is already at least a 9, and then whatever you put here would overshoot this. So this can't be a 4 and it's just a 2. That gives us our first digit. Oh, nice. Okay, so that's a 2. That removes 2 from this set, and therefore removes 3 from this set by the 1-3 pair. This is one of those cells. This, one of these cells are seen and one of these cells are seen. Although I'm not entirely sure which. We can remove 3s from these cells because these must be the same. And whatever this is lies here. This cell will lie here. Oh, because we know this is a 5, then minimally this is 5, 1, 2, which gives us at least an 8. 2 or 3. Oh, this 2 means that's a 3, so this cell is being seen, meaning that those two are the same. 3, 1, 1 gives us a minimum value of 5, so this is at least a 5. That is still a lot of options, but I guess that's somewhat restricted. 1, 3. 1, 3 sees puts a 3 in one of those cells, and I'm not entirely sure how that helps. Oh. Yes, well 4 doesn't work here, does it? Because a 4 here would see that cell. 1, 2, 3, 4. Then this would be a 4, but this would also be a 4. And that would be a 4, which then fails this, because you can't make 3 something something add to 4. So this can't be a 4, that's a 5. Which means 5 is then seen there. So this is then, oh, then that's a 6. Which means this is forced upwards to a 9. So this is 1, 2, and 6. This is then at least a 7, because we knew it's at least a 5, but can't be a 5 or 6. Can't be a 9, so it's a 7 or an 8, meaning that is a 7 or an 8. So this 6 sees that cell, which means that's a 9. That makes sense, because these two sum to 9, which is very easy to accomplish. I was gonna say this cell sees that, but it doesn't have to. It could see a 9 here or there. But it could also see a 9 there, in fact. Because we haven't ruled out 9 out from that square. You know, this can't be a 6. Oh, I'm sorry, this is just a 4. Which means that this cell's a 4. Because it sees that. So this is, what, at least a 5? So it's a 6, 7, 8, or 9. This 4 sees 2, 3, sees that cell, so these two cells are the same. Also means that this can't be a 9 anymore, because you put a 9 here, which then fails that. Sorry, I was being a little preoccupied. This is 6, 7, or 8, because it must be the same as this cell. And I guess with a 4 here, we can put digits in there. These must be a 1, 2, or... Oh, it's a 2, 3, or 4, but this can't be an 8, because then you'd have 2 4s. So this can't be an 8. Removing a 4 from this cell, and removing an 8 from that cell. Okay, cool. Let's see. Oh, interesting. Well, yes. Can this be an 8? That's a really interesting question. I don't think the answer is yes. Because an 8 requires you to put a 5 in total in these two cells, owing to the 3. But can you put... How many ways can you make 5? Even allowing doubling, 5 is odd, meaning you just have to use two different numbers. The possible options are 4 and 1, but this 4 sees both of these cells. So that means it can't be a 1, 4. And this cell is seen by both 2 and 3, so it can't be a 2, 3, meaning that this just cannot sum to 5. Meaning that must be a 7, putting a 7 there. This must be a 6, putting a 6 there. That's a 2. This sums to 4, which can only be made of 1, 3. It goes to be made of 2 and 2, but this 2 here sees that, so that can't be a 2. So it can be a 1, 3, but this means that can't be a 3, so it's a 1, and that is a 3. That's useful, I think. By Sudoku, this must be a 3. This 1 2 pair is resolved by this one here. The remaining cells here are 4 and 8, which is resolved by that. 8, 4. These cells are 5, 6, 8. 5, 6, 8. These can be 6. So this is a 6, meaning that 6 is seen in one of these cells. Not resolved yet. I guess we can do some math here. This can't be a 3, because that would then be a 3 which breaks. So this is a 1, 3, that puts a 5 there, but more importantly this 1 points here, putting a 6 here. Then I remove 6 from these cells, putting a 6 there. Therefore that's a 9, which means that this 3 sees a 9 there. And this can't be a 9 anymore, so 7, 8 pair we have. 1, no, 1 could be anywhere. How about 4s? 4s in one of these cells. Not sure if that is useful. This could be up to a 6, right? I mean, it can't be a 6 anymore, but it could be then up to a 5. 1, 2, 3, 4, 5. Yeah, it could be up to a 5. Okay. I guess we know that it can only be one of these 3 cells then, because it can't be this cell. So this is either a 3, 4, or 5. Although I can't entirely say what is this value. What about 2s? Yeah, in this cell, these cells are seen by that, and this cell sees that. So that's a 2. Anything else? 2's in one of these cells, which doesn't really help. This, I'm not entirely sure. Okay, what about that? This is either, well, a 9 could be here, or I could see this 9. So this is either a 1 if it saw this 9. We don't even know if that's a 9, but this could be a 9, so this could be a 1. But it can't be these, then this is a 5th cell away, so it's a 5, but it can't be a 5. So, 3, 4, let me double check. Yeah, if it saw this 9, then this would be a 5, which fails that. So this must just be a 1, which means that must be a 9. This must then be an 8. That resolves this 5, 8 pair here. The remaining cells here are 1. This one and this one see these cells, making that a 1. These are 7 and 9, which is resolved. Wait. Oh no, did I break the puzzle? I think I broke something. Oh no, I broke something, didn't I? Oh, I broke something. That can't be a 7 or a 9. Oh, I broke something. Okay, 2, 3, 4. I broke something somewhere. I can't figure out where it is though. This is really tough. What cells do we have here? It's just 179. Is this possibly not a 1? I mean, it can't be a 5. So it has to be a 1, right? It can't be a 2, it can't be a 3, it can't be a 4, it can't be a 6. It can't be anything other than that. It can't be a 5. It has to be a 1. But then that just destroys this entire area. Oh no. Oh no. Okay, well then I broke something somewhere. I would assume then it's one of these cells. I'm pretty confident in my idea that this 9126 is correct, which means that double checking 1, 2, 3, 4, 5. So that does in fact plonk a 9 there. This 7 is probably where I did something wrong though. So I'm gonna go all the way back and fix the 7. Could it be 8? Did I miss a step where it could be 8? How could it be 8 though? If this can't be a 2 or a 3, then it can't be a 2-3 pair. And if it was a 4, I mean if it was a 4-1, then now these could be 4. So how in the world could it be 8? Even allowing repeats. A 3 here would put a 2 there, which fails. Oh, what? Did I mess up even further? Or did I mess up in front? That's a 6. That is definitely a 6. Did we identify... This is 6, 7, 8, or 9, right? It can't be an 8 because you put a 4. It can't be a 9 because there's already a 9 here, which would then be seen by this cell. We identified there was a 4 here from this cell here. 1, 2, 3, 4. Yeah. Yeah, I don't see anything wrong with what I've done. That is really interesting though. Because this 9 breaks a lot of other stuff as well. Like in this cell, 9 can't even be in this box anymore. So I think maybe this is wrong. But it can't be a 5 unless this 5 is wrong. But then what? What is it? Did I just mess up? Could this technically be anything else? Hold on here. Did I somehow mess up all the way back here? When I considered the cell that has the 3 right now, when I considered a cell with the 3, I considered cell with the 3 a long time ago, wow. Why did I not consider a 2? Oh, because of 2 down there. And why didn't I consider a 3 here? Because a 3 sees that. And why did I consider that to be a 5, 6? Because this has to see some cells here. You can't see that, because then these would be the same, definitely. Because that's how the arrows work. So yes, we did in fact say that this must be a 5 or a 6. This therefore cannot be a 3. And yes, it cannot be a 4 because 1, 2, 3. A 4 here plus a 5 plus a 1 would make this at least a 10 already. This is... Could this then be a 4? I think maybe something far-fetched was that I assumed this to be a 3. Or my logic told me that this was a 3. But maybe it wasn't a 3. I'm gonna study this a bit more closely now. Could this then be a 4? This is that cell, which is at least a 6. Because a 4, 1, 1 with that there. Yeah, that doesn't work, does it? Because a 4 here would put at least a 6 there, plus the 5 here makes this already an 11. So what is it? Yeah, I don't see what I don't see what I did wrong here. Why did I make that a 7, 8? Right, because it has to be at least a 5, but it can't be a 5 or a 6. Why did I make that a 9? Because a 6 sees a 9 there. If they remove a 6 there, that must be a 4 because it can't be a 5, which puts a 4 there. And then... the 4 helped me prove that that's not an 8. How the heck would I even help to put an 8 there if I can't find a way to put an 8 on here? Could it be an 8 somehow? Like, is there something I'm just not seeing? I don't think so. Yeah, there's something up with my logic. This 4 sees the correct cell, right? 1, 2, 3. Yeah, it sees the correct cell. Could it ever see this? I'll make this a 4, which isn't even possible anymore. Yeah, what the? This has to be a 1, right? Because it can't be a 2. It can't see that. It can't be a 2. It can't see this because that can't be a 9. This would make it a 4, which isn't possible. And this would make it a 5, which also isn't possible. 2, 3, 4, 5, 6. So this has to be a 1 then. It's a 9. Okay, I'm really confused right now. I'm just gonna do this first and ignore the 7, 8 and hope that gets us somewhere. Not entirely sure where else we would go. I see, okay. Well, let's think about this. Whatever this is, 1 has to appear somewhere here. 1 can't appear here, otherwise this would be the same as that. So 1 is one of those cells. That's therefore a 2, that's a 1. This does correlate with my previous expectation that this is a 3, 1 like that. But that doesn't help. I mean, 1's in one of those cells, I suppose. Let's see, this 7 would then be a 1, 2, 4. Ah, but it can't be a 1, 2, 4, so does this have to be an 8 then? Yeah, but then if that's an 8, then this is just a 7, which is true. And then an 8 without a 2 would be a 1, 3, and 4. Okay, this is where it should start to get wrong. There's a 1, 3, 4 pair, that's interesting. Let's see. This is where it might start to get wrong if I, did something wrong in the first place. So this is a 3, 4 which sees either that or that. So one of these are 8s. So none of these are 8s. This can't be a 7 then. If this was a 7, this would be a 9. Then this would be like a 2. So this can't be a 7, it's a 6. This could be either. Maybe that's something this 7 makes that a 9. So yeah, everything I'm doing still in fact points to the fact that 9 goes there. Which means, sorry, did I put a 0? Which then fails this box. So this box is also an issue. Did I mistakenly do something then? Okay, I think we're gonna go all the way back to the start. Where let's talk about, like, before I even do this stuff. From here, where does this go? Can I say... No, I can't say anything about the 9 here. See, because a 9 there would put a 9 there. If this was a 3, then this would be that, which sees all these cells. What was that? I don't remember what that was. Okay. I can't go forward anymore. I reset my progress from here. So, what were we looking at? We're looking at this, right? A 3 would be this. Oh, look at this first. This can't be a 1, because then these two will be the same. Is that correct? Is that correct? Whatever is here, this 1 tells you the distance away. That is therefore that. So I think I'm very confident in saying that a 1 here would fail, because these two would be the same, which fails the column. This can't be a 1, this can't be a 2, because a 2 here would fail that. 2 here implies that this and this are the same. A 3 will imply this and this are the same, which fails. A 4 implies this and this are the same, which is wrong. So this must be a 5 or a 6, which I was very confident about. This therefore can't be a 3, because that implies a 3 cells away. That implies a 3 here, which isn't possible, so this can't be a 3. Can it be a 4? Well, that implies a 4 over here. But the logic still remains that if this was a 4, then minimally this is a 5, 1, making this at least a 10. So this can't be a 4 either. So these are just 2, putting a 2 there. So that's right, I think. So maybe my logic here... Oh, I see. Do you know why? I assumed this couldn't be a 1. That is wrong. Because when I said this can't be a 1, I was assuming that these two would then be the same. That's not true. These two would then be the same if this was a 1. So this could in fact be a 1. Oh, so that's where I went wrong. Why did I make this a 3? I assumed this was either 2, 3 or 4. And I was like, this can't be a 2 and this can't be a 4, because then this would be at least a 6, which fails. So this can actually be a 1 or a 3. And I'm not going to remove 3 because, like, we know 3 doesn't work, but I'm going to find some way to prove that that is not a 3. Some way else. Because I don't want to use bifurcation and say that, well, I did the work with a 3 and it didn't work out, so it can't be a 3. That's not very fair to the puzzle. But what else can we say? Because our next step after this point was to figure out that this is a 3, right? Now that we don't know if that's a 3 or not, what next? Yes, well, we know that one of these are 1s. And this must be at least an 8. I think we can do the same here. This can be a 6. This can be a 9. Why did I put a 1 pencil mark there? Okay, this 4, 5 sees one of these cells. Let's say this was a 5. 5 would then be there. This is either a 1-4 or a 2-3. Now a 1 can't be there because then that would be a 5 which sees that, which is something that actually doesn't work. A 2 would put this here. A 2 would put a 5 there. A 3 would put a 5 there. A 4 would put a 5 there. So, okay, if this was a 5, a 1 doesn't work because a 5 would be there, which breaks this. A 4 doesn't work because a 5 would be there, which then breaks this. So if a 5 was here, this has to be a 2-3 pair. If 4 was here, this would then be a 4, which sees that, which similarly implies that those two are the same. I mean, those could be anything though, anything from 5 to 9. It can't be a 5, but it could be anything from a 6 to 9. Can we do some more arrow interactions? Suppose this was a 1, then it looks at this cell which is equal to that cell. Then this cell is this minus 1. This we still don't know, but I mean, minimally this has to be a 4, right? This could definitely be a 4 though if you just made this a 1-3 pair. Then you have like 2 1-3 pairs here. I'll say this could be anything from a 1 to a 4. I guess we can mark that. It's either a 1, a 3, or a 4. This one we don't know. This one, it's not a 2 anymore. So it's up to 6 now. So anything from 3 to 6. Okay, it can't be a 6. Because a 6 would force it to be a 1-2 pair to make this a 9. Doesn't work. So this is either a 3, 4, or a 5. A 5 here. A 5 requires a 1-3 to make a 9. But it is entirely possible. I need to think a lot more closer. I mean, this can't be a 4 because there's a 4-5 pair surrounding it. So that's something. Oh, I guess, well, if this was a 1, then this is just that. Right? So that's somewhat interesting. Suppose this was a 1. Then, now this could be a 4 or a 5. If we let this be a 5, then this would be a 5. Then this would be a 4 because this is a 1. But that would also be a 4. So you'd have 2 4s in the same row. So if this is a 1, then this can be a 5, meaning that's a 4. Then that fails, because then this must be a 3, which then breaks this pair. This pair can't have a 3 in it anymore. So this can't actually be a 1, that's a 3. What? 2, 3, so these two are the same. And we've finally proven that this in fact can't be a 3 and that's a 1. Okay. Now what that means is that this sums to that. So I can mark that as blue as well. Wow, that was something. In this box, blue is in one of these cells. But blue can't be this cell. The reason why is if this cell was the blue cell, then you'd have this be 4 or 5. This would therefore be a 1 or a 2 because of the 3. It can't be a 2 because of the 2 here, and it can't be a 1 because of the 1-3 pair there. So this can't be blue, meaning blue is here. So I can automatically fill 6, 7, 8, 9 into all of these cells. It'll help me identify pairs, I hope. Okay. So we're going somewhere now. This can't be a 1. So a 1 must be there. And we know a 1 must exist on the arrow somewhere. Okay. Have we figured out anything about these cells yet? We know that this was a 5, then this must be a 2-3 pair. Where was I? What did I say? 1 can be in one of these cells. Oh, we can put in the values for this can be a 6. Because then you put 2 3s here. So this is either 7, 8, or 9, making this a 4, 5, or 6. And then we can remove 6 from all of these. In one of these cells. I'm not sure if that helps or not. I still need to think a lot about where everything else goes, because I don't have any leads with me right now. I want to say 4, that could be blue. It could be, because there's no restrictions on this being blue. So this could be a 4, seeing that cell. And then you'd have 1, 3 remaining to make 8. Kind of 2, so yeah, you'd have 1, 3 remaining to make 8. I don't know. This could be a 2 or 3, right? Does it have to be a 2 or 3? Yeah, yes it has to. Because this can't be a 4. Otherwise you'd have at least 5 here, and with this would make this at least a 10. So this is either a 2 or 3. That doesn't help. I'll say if this is a 6, then this has to be a 2. If this is a 5, then this could be either. So no. Nothing yet. Oh, then this can't be a 1, I just realized. Yeah, because if this was a 1, you'd put this here. This cell would then be the same as that, making this a blue, but we already have a blue in the row. So this can't be a 1, that's a 3, that's a 1. So that is blue. Which means this can't be blue. And additionally, I guess this is blue. Because it's 3. This now, therefore, can't be that cell. So this can't be a 4. I guess we look at blues. Oh, wait, no, did I break it again? Oh no, this must be blue now, but it can't be. Because blue is 7, 8, or 9. Oh no, I think I broke it again. Oh no. Oh, come on. Oh, why did I make this blue? I didn't say this was a blue, because this one is talking about that. So this isn't blue. Who says that's a blue? In fact, this cannot be a blue, because this can't be blue, so that's not blue. Does that help? Well, it definitely puts blue on one of these cells. Because blue can't be that. We already knew that. So this could be a 4, because this could still be blue. I was like, where does blue go? Here. Oh wow, it must be blue in fact. And the reason why is because this blue sees that, and well, this blue sees that. So this must be blue. And in fact, whatever this is here, yeah, because this is a straight arrow and it's not diagonal, you cannot have repeats where it's pointing at. So the rule that says digits can repeat or digits can exist between the value it's looking at and the value itself, that rule is redundant because digits cannot even repeat in a row. So this cell must just be that. And this cell must therefore just be seeing that. It cannot see any other cell, because no other cell is blue. So this is a 4. And that's that, and that is a 1709. A 7 fails because you need a 1, 2 here. So let's remove that from all of these. We can remove a 4 from here then. Does an 8 work? 8 requires a 1, 3, and a 9 would require... A 9 doesn't work. A 9 requires a 5, but a 5 doesn't work because a 5 would either be a 1, 4 pair, which is made incorrect by this 4, or a 2, 3 pair, which is made incorrect by this 2. So this can't be a 9, meaning that all blues are now just 8. So these are all just 8. That must then be a 9. So 8's in one of these cells. I don't need to color that in anymore. We can remove 8 from all of those. This can't be a 7 because a 7 put a 9 there, and 7 is not 1 less than 9, which is, you know, math. So that's a 6, that's a 7, that is a 9. That must therefore be a 7 because of the 1 pointing at it. This must be a 5 by math, this must be a 5 by math, that's a 4, that's a 4, that's a 5, that's a 5. These arrows help putting a 5 there. This 4 puts a 4 there. This 5 means that's a 6, therefore this must be a 2. Okay, we are finally getting somewhere. These must contain an 8 and a 7. That is an 8. Wait, sorry, 8, 7? No, what? 4, 7. Why did I say 8, 7? 4, 7. Not resolved. These cells, too many. Too many to do something cool with it. So these sum to a 7. We know it can't be 3, 4. Can't be 2, 5 because this cell can be 2 or 5, so it's a 1, 6, which can be done if you put a 6 here and a 1 there. Okay, very nice. Five must be here in this box because of these 5s. Yeah, this 9, 6 means that there's a 9 here. Let's look at the 2s again. 2s. So there is no 2 here, meaning that you can't see that 2 goes here anymore. So this 9 can in fact see a 9 here, it can see a 9 there. But it can't see a 9 there because a 9 there will put a 4 here, which fails that. If it saw this 9, it will put a 5 here, which fails that. So this must be what we originally saw it to be, a 1, 9. Okay, that's an 8. But without this 3 here, I think we finally are able to solve the puzzle for real. This is a 7, 3, 3, 7. 3, 7. Can't see anything to do with that yet. This sums to 4, which is a 1, 3 pair, resolved by this 1. These are 6. 6 here means those can be 6. 5 and 9. This 5 resolves that. 9 here, 5 there. These cells must contain a 1. That must be the 1, because that can't be 1. That's therefore a 4. 2, 3, 6. 3 and 6. These cells are 2, 5, 7. These 2 5s means that's a 5. These are a 2, 7 pair. Any arrows we haven't utilized yet? We've utilized all of them, I think. Except this one, we haven't utilized this one. Because a 4 here would see this cell. So this cell can't be a 3 because a 4 can't see a 3, otherwise you put a 3 there, which just makes this arrow totally incorrect. So that's a 6, that's a 3. That puts a 6 here. So that's a 2. 6, no. These cells are a 3, 7. unresolvable as of yet. 3-7 pair means that must just be a 9. These cells must be 6, 7, and 9. I hope that's resolvable. This can't be a 6. This can't be a 9. Oh my gosh. Oh, this can't be a 6 either. So that's a 7. That's a 9. That's a 6. That's a 2. That's a 7, resolving this 3-7 pair. That's a 3. Sorry, that's a 7, and that's a 3. Okay, we're almost done now. I think we've done with every arrow, so that's useful. Oh, that's very good. That's a 4. 2, 6. 2, 6, not resolvable. These, oh, we don't know. Like, there's 4 cells here. I don't want to look at all 4 cells. 2, 2, 7, 9. This can't be a 2. This can't be a 7 or 9, so that's a 2. This can't be a 9, so that's a 7. It can't be a 2 either. That's a 9. That's a 4. This can't be a 7. That's a 9. That's a 7. This is 1 and 9, which is resolvable. This is a 1. 1. That's a 9. This is a 3-4 pair, which we can't resolve somehow. Oh my goodness, there's drilling in the background. I hope you guys can't hear the drilling. 2, 3, resolve by that. 2, 3, how to resolve this 2-6 pair. Oh, I'm making so many errors everywhere I type. Set 1, 7, resolvable. 1, 7. 5, 6. 5 resolves that. 6. 5, that is a 2, no, not a 2, a 4. That resolves this. 3 here, 4 there. 3 and 8 resolvable. 3, 8. There you go, solved. Oh my goodness, 50 minutes. 50 whole minutes. Wow, that is one tough puzzle. Although, to be fair, I will say that puzzle is it only took so long because I made that one singular error here. Well, I said this would have to be a 3. So this can't be a 3. It has to be it can't be a 3. But we proved that without using our bifurcation that we used before. We used this arrow out of all things, which is really unassuming because I didn't know that this arrow would be used until like late game. Yeah. So I hope you enjoyed that. I hope you enjoyed that solve. Alright, I will see you now. Bye bye.